today, in this course of basic mathematics for quantum mechanics, we're going to be talking about complex numbers. And the name's a bit misleading, because they're not really complex at all. So let's start with what are imaginary numbers? Now, imaginary numbers start by saying that there is some number called I, and I squared is equal to minus 1. We know that I squared can't be a normal number, but we can define some symbol called I, which means if we want to calculate something like the square root of minus 4, we can write this as square root of 4 times the square root of minus 1, which is plus or minus 2i. Because if we square this, we'll get minus 1. So this must be either I or minus I. In practice, what this means, we can work as we do normally, but just replacing the square root of minus 1 with the symbol I. Now, imaginary numbers are any number of the form ai, where a is a real number. So that is a normal number that you're used to. Now we can use this to define the complex numbers. And the complex numbers are just numbers of the form a plus bi, where a and b are real numbers. So to give you some examples, we might have 2 plus 3i, or we might have 7 plus 12i, or we might have 6 minus 13i. This first part is called the real part, and this second part, the b part, is called the imaginary part. Now this probably seems kind of abstract, but there is kind of a nice way to visualize this. And the way to do it is just to plot two axes. What we're going to do is this is going to be our imaginary axis, this is going to be our real axis. So we're going to put the a part along here and the b part along here. So if I wanted to represent 2 plus 2i, I would go 2 along the a-axis, 2 along the b-axis, and this here would be 2 plus 2i. Or if I wanted to do something like 3 plus 1i, I would go 3 across and 1 up. So I would get 3 plus I here. Now there are lots of operations we can do on these new complex numbers. The first one we're going to talk about is conjugation. And all this does is send a plus bi to a minus bi. So it sends 2 plus 3i to 2 minus 3i. And we often write this with a bar over the top. So we would say that 2 plus 4i conjugate is 2 minus 4i. We can also talk about addition and subtraction of complex numbers. So the way we define this is in the following way: a plus bi plus c plus di is a plus c plus b plus di, which really just means we add the real parts and we add the imaginary parts separately. So if we have 3 plus 4i plus 2 plus 7i, we get 3 plus 4, sorry, 3 plus 2, which is 5, plus 4 plus 7 gives us 11i. Right, we added the 3 and the 2, we added the 4 and the 7. Subtraction works in exactly the same way. So 3 minus 4i minus 2 plus 3i is 3 minus 2, which is 1. That's minus 4 minus 3, which is minus 7. There we go. Now we'll talk about multiplication. Now, multiplication works just like expanding brackets in high school. So, if we have 1 plus 3i and 4 plus 7i, and we multiply them together, we can multiply them out. So we get 1 times 4, which is 4, 3i times 4, which is going to be 12i. Then we are going to get 3i times 7i, which is going to be 21i squared. And finally, we'll get 1 times 7i, which is 7i. And then we can write this as 4 plus 19i minus 21, because I squared is minus 1. So, putting this all together, we get that minus 17 plus 19i is the answer. Now finally, we can talk about division. So we want to do, we'll start by talking about something simple, or simpler. We'll do a plus bi divided by some normal number c. And this is just going to be a over c plus b over c I. So, for instance, 9 plus 3i, all divided by 3, is just going to be 3 plus I. Now, we can use this to figure out a way to divide complex numbers by other complex numbers. So, we're going to start with the expression a plus bi over c plus di. And we're going to write this as a plus bi over c plus di multiplied by 1. And we're going to rewrite 1 in a clever way. We're going to rewrite 1 as c minus di over c minus di. Using this, we're going to end up with a plus bi times c minus di, and on the bottom, c plus di and c minus di. If you multiply out the top, we're going to get ac plus bd plus bc minus ad times I. And then the bottom is just going to become c squared plus d squared. But this is a real number. So we know how to do this now. So we can write this as ac plus bd over c squared plus d squared plus bc minus ad over c squared plus d squared times I. So let's finish off by looking at an example of this. If I want to do 1 plus 3i over 4 plus 7i, well, I times the top and the bottom by 4 minus 7i. Oops. Here we go. 4 plus 7i times 4 minus 7i. And we expand them out. So we're going to get 1 times 4, which is 4. 3i times 7i, which will give us plus 21. 3i times 4, which will give us 12i. And finally, 1 times minus 7i, which will give us minus 7i. And when we expand out the bottom, we're going to get 16 plus 49. So, simplifying the top, we get 25 plus 5i all over 65, which we can simplify by writing this as 5i over 13. And that's all we need to know about complex numbers for now. In our next one, we'll start looking at what's called the polar form of complex numbers.